Okay, so this is the first video, one explaining a state diagram and your VHDL code for problem one, and explaining the simulations. So here's my state diagram, our document here, and then going into our code, our VHDL, we start off with our libraries, entity, the usual thing. As well as architecture. Here we declare at entity we declare our inputs and output ports, and we have a 6-bit vector for our output, because that was what was on the actual problem that was given to us. It had 3 for, I think it was the north-south, and 3 for the east-west. So yeah. So our state types, go ahead and declaring those. We have 6 states in all, as well as our signals and our outputs. And then moving into the process, we start at the simulation. And starting the simulation, we start with reset, just leading us into our initial state. So we press reset, we go into our initial state, and then here we're just coding that they're saying that on the rising edge of the clock we are proceeding to the next state. Yes. So as our process or next process, we use our car east-west inputs and our current state to determine our next action, basically determine what state we're moving to. So here, when we're in our initial state, our output is as follows. Then if car is not present right here, and while we're in our current state, while we're in state 0, then we proceed to the next state. Otherwise, if a car is present, then if a car is not present, then we remain in our current state. And if the car is present, then we will proceed to state 1. And then when we move on to state 1, our output is as follows. Here I have it described as the south. In state 1, our north-south light is yellow and our east-west light is red. So that's what the 010, that's yellow, and 001, that represents red. And that will be uniform throughout the whole code, or at least that layout between the 6-bit output. Here's what's going on in state 2. Our output is as follows, which are all lights are red, and when we are in state 2, we go ahead and proceed to state 3. State 3, our output is as follows, and we proceed to state 4. State 4, our output is as follows, we proceed to state 5. And when we're in state 5, our output is all lights are basically red, and then in north-south, in our next state, we would proceed to our initial state. So basically the simulation will reset, and we will go back into our previous states up here, or right here. And then here, just connecting all the outputs and the lights. And architecture. And then moving on to our test bench. So yeah, it's basically just the code for the test bench. We have our library entity architecture, again, the component that we're using, which is the full component just stated above, and our signals. Our signals, as well as our device on our test. So that's our port map here, just connecting all the signals together, and and then our clock operation and clock in our car east-west, as well as reset input operations. So waiting for 10 nanoseconds between whether clock is 1 or 0. And for our second process, car east-west and reset, waiting for 240 on each. And here's the simulation. And then, so in proceeding through simulation, you can see that for the lights, that our states are changing, or the light values are changing. So in proceeding through the 6 states they proceed through, and then each of these, again, our clock is continuing to move, but our and we're continuing to move through the states. However, once we get here, our reset is active. Our east-west light is inactive, so there should be no car there, and we remain in this state until it is enabled again and we go through the states again.